All right, so one of the ways that we can investigate common ancestry between organisms is by comparing their amino acid sequences. If you remember, amino acids are generated through the process of protein synthesis, which is where your DNA becomes transcribed into RNA and your RNA gets translated into amino acids that then go on to become proteins. And so what we've got going on in this particular worksheet is that we're looking at a specific protein called cytochrome C that's used by your mitochondria in cellular respiration. And what we've done is we've taken 9 different vertebrates and we're going to compare them. And so we're basically going to be comparing 8 different organisms back to the human: the horse, the chicken, the tuna, the frog, the shark, the turtle, the monkey, and the rabbit. And so if you look, each of these columns is a specific location within the sequence of the amino acids for cytochrome C. And there are a few of these columns where, if you look, every single amino acid within the column is actually the same. And so we can kind of just skip over those because they're already, there's no deviation from the human sequence. So if we look at the second location, or column B, the only organisms that have the same amino acid at that location are the horse and the monkey. In column C, only the monkey has the same sequence at that location. In column D, the horse is the only one that is different at that location. And in column E, every organism has the same amino acid, so we can skip on to the next column, which is column F. And in that column, just like in column B, the only ones that are the same are the horse and the monkey. We can again skip over column G because they all have the same amino acid at that location. And in column H, the only 2 organisms that are different are the tuna fish and the shark. We can skip over column I because every organism in that column is the same. But if we look at column J, every single organism has a different amino acid. The human is we have isoleucine at that location, and none of the other animals have isoleucine at that location. So they're all different. In column K, the differences are in the horse and the tuna fish and the shark. And in column L, the only differences are in the tuna and the shark. Column M has differences in the horse and the shark. And column N and column O don't have any differences at all, so we can skip over them and go straight to column P, where the only difference is in the shark. Likewise, in column Q, the only difference is in the shark. In column R, we see differences at this location for the tuna, the frog, and the turtle. In column S, the only difference is the shark. And in column T, it's the shark and the frog. And then columns U and V together have differences in this amino acid sequence from human to chicken, tuna, frog, shark, and turtle. So now that we have a clear picture of where all of these differences are, what we're going to do is take each row or each animal and we're going to compare it directly to the human. So if we look at just the first row, which is the horse, we see that there are 5 differences. And so in table 1, the number of differences between a human and a horse is that there are 5. And then the next row down is the chicken, and it looks like there are 6 differences. The next row down is the tuna, and there are 10 differences. The frog has 8 differences. The shark looks like it has quite a bit, 14. The turtle has 7. The monkey only has 1 difference in column J. And then the rabbit has 4 differences. So as you turn the page over and you look at table 2, all you're doing is you're rearranging these differences in terms of similarity. So the monkey is the most similar because he has the fewest number of differences. And then after that would come the rabbit, and then the horse, and then the chicken, and then the turtle, and the frog, the tuna, and finally the shark. And so now that we have Table 2 completed, we can actually answer a few of the questions on the worksheet. Namely, number 2 is asking which organism is most closely related to the human, which means it has the fewest number of differences, and that would be the monkey. And 3 is asking the exact opposite. So at the bottom of the table is the shark with the largest number of differences in amino acid sequence. Now, if you remember on a cladogram, things that are furthest away from each other are going to be most unlike each other or distantly related, and things that are closest to each other on a cladogram are more closely related. And we're going to use Table 2 to kind of help fill that out. So with that similarity ranking, the ones that are furthest away are going to be at the bottom. So like the shark would be the furthest away, and then the tuna would come next, and then the frog, and then the turtle, and then the chicken, and then the horse, the rabbit, and the monkey. And this kind of makes sense because we have our mammals that are very close to humans, and the bird and the reptile are further away, as is the amphibian, and then our fish species are the furthest away. And so this makes sense. We have one more question to answer before I leave you to answer on your own. And that's in number 5. We're asked to now compare chicken and horse not to humans, but to each other. Okay, so I've only pulled out the horse and the chicken, and you notice there's a lot more columns now that are exactly the same. And so if we look, there's a difference in column B, in column D, in column F, in column K, M, U, and V. And so that comes out to only 7 differences between the horse and the chicken. And if you look at Table 2, it looks like the horse and the chicken are really closely related to each other because the horse had 5 differences from human cytochrome C, and the chicken had 6 differences from human cytochrome C. But we're not asking anymore about how they compare to humans. We're asking about how they compare to each other. And that's very similar to having a human be compared to a turtle. So we have 7 differences in amino acid sequence between us and turtles. And in the same way, horses have 7 amino acid differences between them and chickens. So can we conclude that the horse and the chicken are closely related? And the answer is no, for that very reason. It's like saying that a horse is to a chicken like a human is to a turtle. And we know that us and turtles are not very closely related at all. So then that last question, the one that you guys are going to be answering on your own, is wanting for you to summarize this concept of using amino acid comparisons and how we can infer the closeness of a common ancestor. And what I would encourage you to do in your answer is reference protein synthesis, that transcription and that translation. That transcription of the DNA into the RNA and the translation of the RNA into those amino acids. Because really what this boils down to is that we all share, that common DNA, and that it's only those sequences of A's and T's and C's and G's that are going to set us apart. And how they set us apart is the code for those various amino acids and proteins. So go ahead and take some time to answer that question, and then you should be good to go with this and put it in on your notebook, page 117.